In this video, I'm going to show you how to fade an LED from on to off using the analog write function. Basically what it does is it pulses the light on and off so quickly that it appears to be fading. This is using pulse width modulation. For this video, you're going to need one resistor that is 220 ohms. The bands are red, red, brown. You're also going to need one LED, and I'm going to be using the Arduino Uno R3 board. I'm also going to be using a breadboard to wire the circuit. Okay, so this is what the code looks like. So first you're going to want to start with writing your integers. You're going to want to put your LED on pin 9. You don't have to, but that's what I'm going to be using. Then you're going to want to state your brightness, which is going to be 0. So the LED is going to be at 0 at its starting point. And then you're going to want to write your fade amount. This is what the LED is going to increase by every 30 milliseconds. I'm going to use 5. You can increase that or decrease that. Then you're going to want to go to your void setup, and you're going to want to write pin mode, and you're going to want to state that your LED is an output. Then you're going to want to go down to your void loop. You're going to want to write analog write because we're using pulse width modulation, and you're going to want to write LED brightness. Then you're going to want to go down below that and say your brightness equals brightness plus fade amount. So basically it's going to equal 0 plus 5 every 30 milliseconds. But if it reaches 255, it's going to do the exact opposite. It's going to decrease by 5 instead of increase by 5. When it reaches 0, it's going to restart and it's going to increase by 5 again. So it's just going to loop through that every single time, from going to completely off to bright, then back down, and then back up again. So once you're done that, you can go ahead and verify. Okay, so now that we've uploaded the code, you can go ahead and start wiring. Just don't forget that the long leg on the LED is the positive and the short leg is the negative. So you can go ahead and plug that anywhere in on the board. Then you're going to want to take your resistor and you're going to want to plug it in with the LED. It doesn't matter if it's on the positive or the negative side, just make sure you have it or else the LED could burn out. Then you're going to want to take a jumper wire and you're going to want to jump the positive side to pin 9. Then you're going to want to take the negative side and put it to ground on the Arduino. So this is a schematic drawing of it. You've got your pin 9 here, then you've got it going to your resistor, 220 ohm resistor, then you've got it going to the positive side of the LED, and then out the negative side you're going to go down and into the ground of the Arduino. So this is the circuit when it's finished. As you can see, the LED reaches its maximum brightness, goes back down, turns off for 30 milliseconds, and repeats again. Okay, so since we're using a digital pin, it can only be either on or off. There's no in between. So basically what's happening is the LED is on and then off for a long period of time, and then it turns back on and off, and that period of time that it's waiting in between is getting smaller and smaller and smaller. So the LED is actually on more than it is off, and that's what's increasing the brightness. So when it gets to the end here, the period of time that it's waiting in between actually gets really short, and the time that it's on is really long, and that's what makes the LED appear very bright. And when that period of time is very long, that's what makes the LED appear very low, but it's happening so quickly that you can't even see it. Thanks for watching, guys. In my next video, I'm going to be showing you how to hook up a switch to your digital, and I'm going to show you how to use it as an input instead of an output using a switch, and I'm also going to show you about pull down, and I'll explain pull up resistors as well. Thanks.